Okay, so this is GeoGebra. I'm sure you may have seen it or heard of it in other math classes before. We tend to, as math teachers, default to Desmos because there are a lot of really cool things that you can do on Desmos that I think are done better on Desmos than on GeoGebra. I don't find GeoGebra to be very easy to manipulate. I think that there are some problems with how they programmed the application. But I could talk to you about that all you want if you want to hear about it. But this is GeoGebra. And the one thing that I do think GeoGebra does really well is that they have a lot of shortcuts. They have a lot of shortcuts, and they have a Voronoi diagram shortcut. So if you type in geogebra.com and then it automatically filtered me to .org. So I guess it's .org, but it doesn't even matter because it'll just bring you to the place you want to go. And you click Start Calculator. You come to a screen like this. Now, what I'm first going to do is I don't like the grids in the background, especially when we're doing something like this. So I just clicked on Settings, went to Show Grid, and just said, No grid, please. And then you can click and drag it around. And what we're going to do is add in an image. So we're going to click here on the plus and go to Image. And then we're going to choose File. And then we've got some silly pictures and some math pictures. And we're going to open up that guy and plug it in. And now this is the diagram that was on your notes. I just went in and copied it out of the notes and put it and saved it as a picture. And then you can insert any picture you want into GeoGebra or into Desmos if you actually wanted to program it, because you can go into Desmos and program a Voronoi diagram. It's just takes a long time. And what I would like to do is I would like to line up this guy such that the coordinates on this image match up with the coordinates on this program. So what we're going to do is you can click on this guy, and then down here you have options, and this one is your transparency. So I'm sliding it back and forth to make it less transparent. And the reason why is I want to be able to bring it down such that the origin on my image is the same as the origin on this map. And then once I've brought it to a place where they seem to be the same, I'm going to make it bigger or smaller to try and get the numbers to match up. So I want my 2 and 4 and 6 and 8 to be all aligned. So I'm going to look at that both on my x-axis and my y-axis. As I'm getting smaller, it's getting slightly pushed to the left. So I'm going to be a little nitpicky about this. And drag it. And we're almost there because my 10 on my y-axis seems really not in the right place. There, and I think that's about as good as we're going to get. I'm going to make it as opaque as possible again, and then now, since it's perfectly aligned with the actual origin and scale, which is important that we have the same scale on our image as we do on our map, I'm going to go in and turn off, stop showing the axes. So then now, as long as you don't click on the image and then drag it around, if you just click on the open space and drag it around, you can kind of zoom in as you want. Now, there is a command for those of you who have taken programming before. This is just like Desmos. It can be used and interpreted and explored and discovered as a programming tool. So if you just type in Voronoi, you'll notice that just like with programming in Excel, just like with programming in Google Sheets, they're like, do you mean this? And we're like, yes, we do mean that. And so it asks us to give them a list of points. But we don't have any points. We have points that are on the image, but they're not registered on this programming tool as points. So what we have to do is if you click over here to Tools, you can see Point. And we're going to go in and click on all of these except for P. To make points. Notice that points A and B are the actual two out of the 4 corners of our image that we put in, and that's because of the mathematics behind dilations, or mathematics of dilations behind scaling an image on a computer. There's when you're programming how to scale something is you actually triangulate an image. And so those are 2 out of the 3 points that they've chosen for this image, that when you click one, it isolates 1 point and then creates a scale factor on the other. Anyway, it's cool mathematics that you learned about in maybe 8th grade when you talked about transformations. And that's why they had to label 2 points on the image. But just realize that A and B are not part of our points that are actually on the graph. It started with C. Important, because when we go back down to our Voronoi diagram, which this guy is a pain in the butt. There you go. So then this way, we're not going to start with letter C. We're going to start with letter C. We're not going to start with letter A. We're going to start with letter C. I turned on my caps lock because these are all labeled in capital letters. So that's why it's quickly doing that. And it's all the way down to K. And as you can see, as I was typing in these points, that the Voronoi diagram just started popping up. And if I wanted to get rid of any of the points, like let's maybe say that G was no longer there, maybe the water scale, or the water, what are those called? The water gauges at G were swept aside by a storm or something. And so now you need to have a different way of accurately measuring what's happening at P. Then you would adjust and delete G as an option. And then now you can see that F has become the closest one if G is not there. But G is there, which means that G is the closest possible water gauge to the point P. Now it's really on the edge, but still, since G is the closest one, we're going to use that information to then make an interpolation, a guess of about how much water is falling at point P during this time. And we're going to say that that's, I think it's what, 0.63. If I go in here and click on that bubble, it turns on and off the point. It's still there, right? The Voronoi diagram hasn't changed. We're still calculating it. It's just that we can't see it now. And the gauge there is 0.63 cubic inches, which means we're going to estimate, interpolate that at point P, 0.63 inches have fallen.